At the end of the last video, I gave you these two problems and asked you to give them a shot. So let's just work through them together. I always like to, if I'm evaluating an inverse trig function, I like to give it a name that makes me think angle. So I'm going to call that theta, and then I can say what this means is that sine of theta is equal to negative root 2 over 2, and theta's in the interval from negative pi over 2 to positive pi over 2. So that corresponds to either quadrant 1 or quadrant 4. Okay. So I'm going to look at this. I'm going to say that's a negative number. That's the sign. Well, sine is negative in quadrant 4. So I now know I've got to be in quadrant 4. Okay. So my theta is going to be a negative acute angle. Okay. So I basically am using the sine, S-I-G-N, to figure out what quadrant I'm in. Then I'm going to look at the absolute value to figure out my reference angle. If I call the reference angle alpha, okay, I know that sine of alpha will be the absolute value of that number. Because the reference angle, I always count as a positive angle. So here, theta is going to be a negative acute angle. The reference angle is always positive. So theta is just going to be the opposite of alpha in this case. But because alpha is always a positive acute angle, any trig function is always positive. So it has the same absolute value, but if the sine of theta was negative, I'm going to have to drop that negative when I'm working with the reference angle. So then I say, well, what is the acute angle that has a sine of root 2 over 2, and I go to my 45, 45, 90 triangle, and I can see that sine is 1 over root 2, and I've rationalized that enough that I recognize that that's going to give me root 2 over 2. So in degrees it would be 45, but that means in radians it's pi over 4. Okay. So I'm looking at an angle in quadrant 4. Its reference angle is pi over 4. Do be very careful though. I'm not going to get to quadrant 4 by coming around like so. That's right out. Okay. Because if I did that, when I put that along the x-axis, our quadrant 1 was from 0 to pi over 2, so I kept this interval. And then if I go around that way, we're talking about from 3 pi over 2 to 2 pi. That's quadrant 4, but it's not connected to this. The version of quadrant 4 I want is the one that's adjacent to this, which is from negative pi over 2 to 0. So I have to get to quadrant 4 by rotating in the negative direction. So that tells me that theta will just be negative pi over 4. Notice I'm essentially doing a two-step process here. I am using the plus or minus sign to figure out what quadrant I'm in. When I'm evaluating regular trig, I use the quadrant my angle is in to figure out whether the trig function is positive or negative. Here I'm just doing that in reverse. Then I use the absolute value of the trig function to find the reference angle, which is the acute angle that has that as its trig ratio. Okay. Now when I'm evaluating regular trig, I use the reference angle to get the absolute value. Here I'm going in reverse. I'm using the absolute value to get the reference angle. And then I just put the pieces together, making sure that I get into the quadrant the appropriate way. So when it's quadrant 4, I don't rotate almost a full revolution. I rotate clockwise, so I'm getting a negative acute angle. All right, excellent. So that was our first one. Let's try the second one. Again, I want to give this a name that makes me think angle. I'm going to call it theta. Now, obviously, it's a different theta. I'm being very creative with my names. Okay. All right, so what this means is that sine of theta is negative 1, and theta's in the interval from negative pi over 2 to positive pi over 2. Now, usually I would think in terms of quadrants, but I sort of recognize that negative 1 is a very special value. I only hit that at quadrantal angles. So I'm not going to be in either quadrant 1 or 4. I'm going to be on the boundary. I know that if sine is -1, I've got to have an angle whose terminal ray passes through the negative y-axis so that it hits this point right here, and the capital Y value is -1. So there are infinitely many angles that do that, but there's only one in this interval. This is going from -π/2, oh, that looks like it, to π/2. So my theta in this case would be -π/2. Excellent.